Hello, my name is Zoë York, and this is my Genetics 311 Exam 2 mini video. This is my cat Oliver. Since he has such an amazing cat who can skateboard and even models for PB Teen, we would like to breed him to get more baby Olivers. We really want another cat just like him, who is tailless, has long fur, and is friendly. Luckily, these three genes are all passed down on chromosome 4. Three genes being passed on are fur length, of which long fur is dominant to short fur, tail length, of which having no tail is dominant to having a tail, and personality, of which friendliness is dominant to being mean. Luckily, these three genes are all passed down on chromosome 4. This is the genetic map showing the three loci and the distances between them. We know that there is a distance of 12 centimorgans between the loci for fur length and the loci for tail type. Then there's a distance of 8 centimorgans between the loci for tail type and personality type. We also know that the coefficient of coincidence is 0.9. With this information, we want to determine all the possible progenies we can get. Before we can do this, we need to determine what Oliver's genotype is. We know that his mother had short hair, was tailless and friendly, which gives her a genotype of little l, big T, big F, little l, big T, big F, and his father had long fur, a tail, and was mean with the genotype of big L, little t, little f, big L, little t, little f. Both of the parents were pure breeding, so any recombinant event that occurred would not have any impact on the gametes of F1 generation, meaning Oliver as F1 generation received the little l, big T, big F gamete from his mother and big L, little t, little f gamete from his father. In other words, any progeny from his parents would be heterozygous for each trait. Knowing Oliver's genotype, we can utilize the genetic map to determine any possible crossovers. There are 4 different types of crossover events that can occur. No crossover, single crossover at position 1, single crossover at position 2, and a double crossover event. And each of these events produces 2 gametes. If no crossover event were to occur, the 2 possible gametes produced would be little l, big T, big F, which otherwise short fur, no tail, and friendly, and big L, little t, little f, long fur, tail, and mean. If a double crossover event were to occur, we would produce a little l, little t, big F gamete for short fur, tail, and friendly, and a big L, big T, little f gamete, which is long fur, no tail, and mean. We would prefer for a double crossover event not to take place. Luckily, we can calculate the probability of a double crossover event taking place. We know we can calculate the probability by multiplying the distance between the loci with the coefficient of coincidence. Multiplying 0.12 by 0.08 and 0.9 results in a probability of 0.00864. The probability then of getting either game from a double crossover is 0.86%. Using this, we can also calculate the probability of passing down just the specific short fur, tail, and friendly gamete, little l, little t, big F, by multiplying the double crossover event probability by 1/2, resulting in 0.00432. If a single crossover event occurs at the first position, we would get a little l, little t, little f gamete for short fur, tail, and mean, and a big L, big T, big F gamete, long fur, no tail, and friendly. We can calculate the probability of a single crossover event occurring at position 1 by subtracting the probability of a double crossover event occurring from R1, which is 0.12 minus 0.00864, which gives us a probability of 0.1136, or 11.136% chance. Now you may be wondering what the probability of passing on the specific big L, big T, big F, long fur, no tail, friendly gamete is, which would result in the progeny having the same phenotype as Oliver. We can calculate this probability by multiplying single crossover position 1 probability by 1/2, getting a probability of 0.05568, or 5.568% chance. If a single crossover event was to occur at position 2, we would get a little l, big T, little f gamete, which is short fur, no tail, and mean, and a big L, little t, big F gamete, which is long fur, tail, and friendly. To provide you a better understanding of how I determine the probability of each of these events occurring, I utilize this table and these formulas to calculate these values. As a whole, we are most likely to see no crossover event occur, as the probability of no crossover occurring is 0.80864, or an 80.864% chance. The next event that we are likely to see occur is a single crossover at position 1, with a 0.1136 probability of occurring, or 11.136% chance. The third least likely event to occur would be a single crossover event at position 2, and the probability of this taking place is 0.07136, or 7.136% chance. And it is especially unlikely for a double crossover event to occur, as the probability of one occurring is 0.00864, or 0.864% chance, which is less than an even 1% chance. To better visualize the probabilities of each gamete occurring, I have created this table to centralize these probabilities. We also know now that for any offspring to look just like Oliver, we would have to have a single crossover event occur producing the big L, big T, big F, long fur, no tail, friendly gamete. Unfortunately, there's only a 5.568% chance of passing on this gamete, and the majority of the offspring will either receive alleles for short fur, no tail, and friendliness, or for long fur, having a tail and being mean, as we will likely see no crossover event occurring. In the end, we have only taken a look at the possible progeny from Oliver, and any offspring's genotypes would also be dependent on the gamete from the mother as well. I hope you now have a better understanding of crossover events.